So today, going to talk about reinforcement learning. You can find the page. If you get to the Data Lab GitHub page, we go to classical machine learning, and then we end up in this wiki page. And today we are talking about reinforcement learning. I can share the notes directly. Thank you for coming. So let's start talking about what is reinforcement learning. And since this workshop has been focused on machine learning, we are now going to talk about the third type of learning. There are more than three types, but these are the main ones. So what is reinforcement learning? And so we will have, in reinforcement learning, we don't have any labels of the data, so everything has to do by rules or functions or values. And the algorithm will try to find only the steps that that receives most of the rewards. And also, for example, if you are in a maze and you're trying to find the way out, you may do a turn some point, and the reward is not instantaneous. Later you will know that that wasn't probably the best way, or it was the best way. Then time matters because it's a temporal sequence of steps, for example, and whatever step you take in a maze, it will have some consequences or subsequent data. So in reinforcement learning, we're always looking for rewards. And a reward, for example, if you are flying a helicopter, as long as you can manage your controls, you are getting a positive reward. But as soon as you crash, then that's a negative reward. The same thing as if you are driving a car. And also, in every model of reinforcement learning, there's going to be an agent, and that agent is going to be doing some actions, and consequence of its actions, it will receive positive rewards or negative rewards. And the agent will try to maximize the cumulative rewards. Okay, and then there is a reward hypothesis that all the goals can be described by a maximization of the expected cumulative reward. Okay, and let's talk about some examples. This is a classical example of training a model. So the dog is the agent, and it's going to be in some state, and then it's going to change the state by performing some action. And if the dog catches the ball, he will receive a reward. And if he doesn't catch it, maybe he will try again until he gets the reward. So this is the basic model for reinforcement learning. And so the components of a reinforcement learning, we will have states where the agent is, and we will have actions, we will have rewards, and then we will have probably policies. For example, if you're trying to get out of a maze, you're looking for a way of going out. You may have returns as a reward. Like, for example, you go into a deeper rabbit hole inside the maze, or you may go to finding the correct way out. And then value functions, let's say you have a cost if you trying to come out from a maze in a minimum time. Um, Probably if you took a wrong turn at some point, then it will cost you. And then the environment is how for example, the maze or the everything is interacting with the agent. So these are just key concepts that we were talking when we will be reviewing the topic of reinforcement learning. There is a classical reinforcement learning, and also we have deep reinforcement learning where we have to involve neural networks, for example. And the neural network is just going to be a black box, and uh, we will design our model to get the most rewards. So there is a simple example here of a dog catching a stick. So we can play with it. This is using Hugging Face library for reinforcement learning. So let's open it and you can play. If you get an error, yeah. So the model is we have a dog and we are going to train him to catch the stick with a deep reinforcement learning. Okay, so let's start here. Escape, and you just press play. And then with the mouse, you just throw the stick and the dog will try to catch it and bring it to you, right? Okay. Just press the mouse and throw the. So this is an example of deep reinforcement learning. And you can find different libraries in the Hugging Face to program your models. Okay. Okay, let me go up. All right, so that's an example. And other examples, we have AlphaGo Zero, which is a system developed by DeepMind, Google DeepMind, and it's supposed to just play the Go game. And this this machine learned how to play the game of Go, and it's just moving and trying to block the opponent with different stones. Um, and this system was able to beat the opponent. So the idea is just trying to block the advancement of the opponent. And so this is a system just developed with reinforcement learning in order to play the game of Go. Another example is this frigate bird, and it's just like a system that it's doesn't have any motor, so it's just taking advantage of the different winds in order to stay on flight. It's taking a while. This system was developed by Microsoft. Yes, so okay, thank you. Nothing there. It's just something that is the when you throw this object, it will just take advantage of the different winds and currents in order to stay on flight and maximize the flight path. Okay, so let's go back. Another system is for locomotion, also developed by DeepMind. Let's see if we could get there. Yes. So it's just a movement of this type of dummy that is running and trying to go over different obstacles, and as it goes, it will learn, or this model was trained So there was a number of examples where the model failed and then tried to learn from the failures until it can perform better in that environment. So that's another example of reinforcement learning. Let me stop this. And we have other types of applications. For example, in a data center, trying to develop a way of maintaining the data center cooled. And in this model, just playing with different temperatures and probably fans, they were able of saving the energy by 40%. Also, you can find other applications like controlling nuclear fusion plasma. It's another example of reinforcement learning. Okay, so just the general knowledge of what is reinforcement learning. So the next thing we're going to do is open a Jupyter notebook with examples. And in that Jupyter notebook, I have two examples. So if you open it and then launch it in Google Colab, you will have something like this. Okay. So there are several libraries depending on what type of example you're trying to work in reinforcement learning. But there was initially a library from OpenAI, which was called GYM. And now there is a fork out of GYM, which is called Gymnasium. And you can find all the information of this other library for doing reinforcement learning. Okay. And we're going to do two cases of this library. One will be on the lunar lander, which the objective of this game is that we need to train this lander that has several actions to perform, like for example, starting the engines from below or from the sides, and also the engines will stop once the lunar landing is on the ground, etc. So we need to train this model. And the other example will be, it's going to be here. Let me go back. Okay. So let's start. We need to do some installations first. So let's start this suite library installation, which is just connecting programs with C and C++. And then we will install a physics engine, which is called Box2D. And this is going to be for the lunar lander. So there are these models that take care of all the physics, and they are called physics engines. And this is one of the basic ones. We're going to install it. And then after it installs, the box 2D is also included in the Gymnasium. Let me go back. Introduction. Yeah, box 2D. Is this just takes care of all the physics? For example, for this bipedal walker, or if you're doing car racing or the lunar landing, the box 2D is just the physics engine behind that. Okay. Okay, still installing. And then we need to install some visualization properties on Google Colab. So we need to install these libraries for doing, for displaying images and animations. So, okay, so go and install these visualization libraries called Piglet and the XV framework. And also, once we install that, then we can import the gym library, which is the gymnasium for reinforcement learning. So we import it, and then, okay, we install this one, just display. And then these are just the requirements, and then we will install the basic uh, Python libraries like matplotlib for visualization, pandas, and also we will have to we want to show some YouTube videos inside our Jupyter notebook, so we import this IPython display YouTube video. We do it, and then we define some properties of the displays. So now we can do the lunar lander. Okay, so the lunar lander has these actions: to not do anything, to fire the left or right engines for orientation, and also to fire the main engine to when it's trying to land. This is the action space. And then the observation space, it's a 8-dimensional vector that it has all the coordinates, X and Y, the linear velocities in the X and Y directions, the angle, and the angular velocity, and also two Boolean variables that represent if the leg is in contact with the ground or not. And well, the rewards is just trying to not to crash into the surface and do a perfect landing. So these are the rewards. And the starting state is just a random point. And then the lander game or simulation will finish if the lander crashes or if the lander gets outside the viewport, I mean going out of the frame, or the lander is not awake. It means that it's just inert. And we have a video of this, so we can play. Yeah, okay, now I got it. So this is a video that we are going to produce in a couple of minutes, and it will just show the different trainings for the lunar lander, and we will produce a video with this output. So these are different realizations of the lunar landing trying to land on the surface. Okay. So you get the point. So let's now try to obtain a video of this. Okay. So I'll stop, go back. All right. So I'm going to install the box to do from 2D from Gymnasium. And then I'm going to import Gymnasium, which is just a fork from the OpenAI Gym. And you will see that when we are going to train our model, it will take some time. So we need some computation time in order to have a trained model. And the trained model will learn how to maximize the rewards. So in our case of the lunar lander, well, the reward is trying to land on the moon without crashing. And by the way, we will need two extra Python programs. One is called agent class, and the other one is run agent. And we need to upload into our Google Colab. And you will find the links for these programs. And please download those programs into your computer and then use the upload function from Google Colab to upload the two programs. So I already have them with me. So I will upload and oh, I need to find them. Yes. I need to upload the agent class, open, and the run agent. Upload run agent. So now I have the two programs here. Okay, so I have installed the Gymnasium Box 2D. I need to import all the libraries. Now I have these two codes sitting on my session, Google Colab session. And if you copy the path for each program, it will show you the path. For example, for the agent class Pi, the path is just slash content slash agent underscore class Pi. And this is the way of loading external Python code into your Jupyter notebook using the command %load. So I'm going to do that. So this program, we're not going to go into the details, but it's just creating an agent class, and also the run agent. We load it, and then we import the agent class and call it agent. Okay, so now we have the agent and how to run the agent. Then we will try um, to start our environment for the lunar lander version 2. And we have several variables for the actions, the observation, where the lander is, and the states. And you will see that we have a two-dimensional space, state space, and 4 actions. And the actions, remember, is just do nothing or just start the left or right engines or the main one. And then we create the agent class with these parameters. Now we're going to train our agent. We will train our lander to land, and it will, oh, I need what? Oh, that's fine. Now what? That's a new error for me. Go back. No, it's not going to work. Okay, what can be? Okay, so last night it worked, and actually it took about 7 minutes of CPU to train the model. Um, Now it's has this error, runtime error. Probably I'm just mixing too many gym libraries. So try again, and then load, load, import, initialize, parameters, train agent. No. Okay. Let me continue. I have just have memory for all what our results were. So here we're just training results on the different keys for the episode. The episode is the number of times we do a simulation. Then we plot the training stats, and um, we get a plot like this. So this is the duration of the episodes until the model or the agent is getting maximizing the number of the maximum of rewards. So in this case our goal was to that our model will receive around 200 a value of 200 rewards. So this is where the model starts learning, and then the model will try to maximize the rewards, and this is the number of episodes it took our model to reach our goal of 230, the reward of 230. And then we can create a video out of it, and then do the different runs. In this case, I'm going to make 20 runs, and then I'm going to create a video, and at the end I will have a video, which since my code failed, I cannot reproduce the video. I need to get back to you with what type of error. I'm thinking of mixing two types of libraries, the one from OpenAI and the one from um, Gymnasium. So let me go. So, okay, all right. So that's probably what happened. I'm just mixing two libraries. So I'm just going to assume and continue. And then I will clean my Jupyter notebook. Okay, so that's the example how I created the lunar landing video last night, and everything was fine, but I deleted some of the cells that were not working, so probably I just mixed libraries. But anyway, we go back. The next example is shows you how to train the card poll, and the card poll is another system that only has 2 degrees of freedom. You can move them left or right. The idea is just to maintain in equilibrium the pole. So like handling handing a pencil and trying to balance the pencil, just moving the base of the pencil. And so the variables will be moving left or right, and also we will have some angle of the pole, and also we will have some angular velocity. So those are going to be, so the action space is push the card to the left or to the right, and the observation space will be the position in the x-axis. So it goes from minus 4.8 to 4.8. The velocity can be any, from minus infinity to infinity. The pole angle can be like from minus 24 degrees to up 24 degrees. And the angular velocity, the velocity of rotation, can be any value from minus infinity to infinity. Okay, and then rewards. Well, we're trying to keep the pole upright as long as possible. And also we will set a value of 500 for version 1 and 200 for version 0 of the library. So in our case, I think we're going to use version 1. Version 1, yes. And here there is a video over in YouTube where you can see the card poll simulation. Okay, so now in this part, we're going to install all these libraries. We import gym again, and we're going to use PyTorch, and we're going to use some library from PyTorch, AutoGraph, and other libraries, random from creating random numbers, Matplotlib for visualization, Hill for image manipulation in Python, and also display, math, torch vision transforms, and NumPy, and also time. So I run that. Then I'm going to define my environment for the carpal version 1, and we're going to define several functions, and we will have at least this is the initial image of our system. Now, I'm not going to create an animation, but I'm going to look at how fast our system can learn. Okay, so we're going to define several values, several functions. So, and then we will, in this case, in this example, they use a random search. So in order, instead of trying to guess what would be a good initial values to start, we will just take random values from the state space, and then probably we will reach our stability in less time. So that's a random search. And then we will see if we run 150 episodes, how fast can we get into our score. So these are the number of episodes, and this is the scores in the last 50 episodes. So we're trying to reach a goal of 200 or near something 200, and this is the system trying to learn and maximize the rewards, but also actually it's not learning, so we need to take advantage of whatever advance it made for a good reward in order to remember how it got there. So it's not going to reach anything after 150 episodes. Okay. Okay. So we need to teach the system how to learn. So we're going to use this algorithm, the deep Q learning, and we will run it. So you see the system, our model never learned. So we need to use this algorithm for teach our system. And this learning will have different parameters. There's a learning rate, I think is epsilon. Yeah. And then we will use this algorithm. And we will define some parameters, 150 episodes, and a learning rate of 10 to the minus 3. And then we're going to start this algorithm, okay? And it's going to be similar because in the next step, we will try to take advantage of whatever the model has learned. So here it's just the first time it's trying to learn how to reach and get the maximum reward. And our goal is around 200. So every time the model gets better, because it has a very small learning rate, and every time it's trying to maximize the reward. So now you can see there is a growing curve, and we're trying to reach a goal in 150 episodes. Okay, and that is taking some time. Okay, we just have one case, right? All right, so the next algorithm will try to take advantage of the previous run in order that the algorithm takes advantage of what it learned before. So in this case, we didn't reach our goal only once. So we're going to try to take advantage of the memory of the model. So we're going to use this function, which is called replay. And we're going to replay using the old function. And we hope that we can reach the goal in less time. You can see the average time of the replay is less than uh, 3/100ths of a second. So we're just watching how fast our model learns, and we almost reached our goal for rewards. And we have reached our goal in less than 50 episodes compared to the previous case, right? And this is the learning rate. So now we have a system that it's has maximized the reward. Okay. So we're using the Q-learning reinforcement learning algorithm, and it's using neural networks. So it's just a black box for us, but it's doing a good job. Okay. So you see now I am getting good rewards in less than after 50 episodes, everything is now fine. So probably we will see that we are balancing very well the pole. And we even get higher scores of 500 some points. It's taking advantage of what the previous run, so now it's faster. And we will finish at 150 iterations or episodes. Okay. And you can see the scores are above 200 um, for every 50 episodes. Now we can do something similar using this replay function, and you will see that this will be also fast. And after a few episodes, it will start increasing. Now, there is some critics about to these algorithms that they they get they get high scores very fast, and that may introduce stability problems to the algorithm. So in the next case, we will show a new algorithm that will take care of this rapid growth of or achievement of the maximum score for our model. And that will be the double QL algorithm. So now our model is just achieving high scores. Uh, above, way above 200. Okay. So our agent is learning and it's trying to maximize the rewards. So now it knows how to get maximum rewards. Okay, this will continue up to 150 episodes. Okay, okay, okay. All right. So as I mentioned, there is the possibility that our algorithm or our agent is learning very fast and obtaining very high scores, but that can introduce instability in our models. So there's another model which is called double Q learning. And so the idea is that after every episode, there is a weight added to the previous state. And um, what we can do is try to not assign equal weights every time, but also update the weights after a certain number of episodes. So we're going to update the rewards using uh, the following functions. So we're going to define this function and then we're going to run it and we're going to update every 10 steps or every 10 episodes. And this is how the model will learn. So we have, so we're trying to reach the 200 level for rewards. The only difference now is that we are adding different weights to the previous steps, but after every 10 steps or every 10 episodes, we're changing the weights. So the model can be more stable in obtaining or achieving the maximum score. Okay, so we see how this algorithm is behaving more stable, it's not overshooting, and it's staying around the decided goal of 200. Okay, so that's the difference in this new algorithm compared to the previous one, and has finished. And if we remember how was the previous one, you see that we overshoot and everything is above here, but that is not good for the algorithm. This is our goal of 200. Okay, so just in general terms, that is what people mean by reinforcement learning, where you have an agent and you are training the agent in order to get some rewards. Um, so it can be any, like for example, autonomous vehicle trying to stay on the path, and there is a learning process, and also we don't have to, the user doesn't have to do anything. The algorithm will just do it by itself. We just need to come up with the appropriate parameter values in order to achieve our desired behavior. And well, I'm sorry that I mixed up my code, but it was running and I produced last night, so probably just mixed different libraries. So I need to find out what I did wrong, and then I will just update the notebook to run again. So are there any questions? So when you see something about reinforcement learning, you will know what it means. And that's what I have today.